We look at a finished bridge deck or a highway pavement and see the ultimate symbol of stability. In our default view, infrastructure is solid, silent, and permanent. But the interior is an actively shifting environment. Moisture drifts through its pores, chemical reactions persist, and microscopic crystals slowly grow within empty voids. Concrete is not dead stone. When a hairline fracture finally appears in a structural wall, we often assume we are witnessing a sudden event. We treat the crack as the explicit moment of failure. In reality, that visible fracture is a lagging indicator. For years, the material has been quietly absorbing thermal stress, expanding, contracting, and fighting off chloride infiltration deep within its matrix. The crack is not always the beginning. Sometimes it is the confession. Traditional engineering often relies on recipe thinking. We combine specific amounts of cement, water, and aggregate to reach a target strength. This mixed ticket presents a perfect mathematical ratio. However, relying strictly on this document creates an illusion of control over what is actually a highly dynamic chemical system. The mixed ticket tells us what was intended. The route tells us what the concrete actually had to survive. Concrete is not a recipe. It is a route through time. Vulnerability is born in the gap between static mathematics on the page and the chaotic environmental reality the material faces in the field. The early life of concrete is a timeline of admissibility gates: batching, transport, and placement. During open time, traffic delays or temperature spikes pull moisture, stressing the mix. During curing, hydration is an active chemical fight to build bonds while managing intense heat. Concrete does not prove itself when it becomes hard. It starts proving itself while it is still trying not to fall apart. Industry standards often assume passing a 28-day compressive strength test, hitting a megapascal target, guarantees longevity. But crushing a sample in a lab doesn't prove the internal pore structure can survive 10 years of freeze-thaw cycles. A high strength rating is only one variable. The true objective is controlled survivability across the entire timeline. Every gate crossed during the concrete's route generates data regarding its chemical and physical survival. When this information is fragmented between contractors or lost in laboratory files, the project's risk profile scales upward. Missing evidence is not a nuisance. It is the debt the decision has not yet paid. Bridging the gap between the mixed ticket and the real world is the fundamental task of operational engineering. Concrete RouteCheck and RouteMaster function as a forensic ledger system. It organizes the evidence, comparing intended mix parameters against the actual variables recorded along the timeline. This system does not replace engineers, laboratories, or certification standards. It organizes their data into a coherent audit of the route. RouteMaster does not replace judgment. It helps judgment see the route. The massive infrastructure of the built world rests on actively managed systems of material survival. The videos are the gateway. The books and papers are the foundation layer.